Here we see the results of Nordhaus's mathematical miracle. After choosing his best estimates for relevant parameters such as climate sensitivity and damage functions, the estimate for social cost of carbon from his DICE model ranged from $27 to $966 for different discount rates in 2020. In other words, the social cost of carbon almost seems to be determined by the discount rate we choose. What is a discount rate and which rate is appropriate, you may wonder, especially if you are a student from outside of economics. The discount rate refers to a rate used to express future flow values in discounted current terms. In other words, the rate determines how we weigh the present in comparison to future outcomes. With the topic of discounting, we arrive at the second reading included for today, Arrow et al. 2013, with a plea for using discount rates that decline over time. Regarding trade-offs involving the present and the future, Arrow et al. 2013, page 349, explains the concept of discounting future outcomes. There are two rationales for discounting future benefits. One consumption and the other investment-based. The consumption rate of discount reflects the rate at which society is willing to trade consumption in the future for consumption today. Basically, we place a lower value on the consumption of future generations because we assume that future generations will be wealthier than we are and that the utility people receive from an extra dollar of consumption declines as their level of consumption increases. The investment approach says that as long as the rate of return to investment is positive, we need to invest less than $1 today to obtain $1 of benefits in the future. With a declining discount rate schedule, benefits and cost in a given year are discounted at the same rate, but the rate declines over time. Arrow et al. Argue for the adoption of a declining discount rate in benefit cost analysis of projects with long time horizons because, as it says on page 349, uncertainty about future discount rates lead to a declining discount rate schedule. The paper illustrates this with the following example. Suppose that we think the interest rate is equally likely to be 1% or 7% in 100 years. We evaluate the net present value using its expected value averaging the results obtained using the 1% and 7% rates. As the table illustrates, uncertainty about the discount rate combined with constant exponential discounting will always yield a higher expected net present value than using the mean discount rate with 100% certainty. The declining discount rate schedule makes a considerable difference to estimates of the social cost of carbon. That is the present value of damages from emitting a ton of carbon dioxide, when compared with using a constant exponential discount rate. Estimates of the social cost of carbon are increased by as much as 2 to 3-fold by using a declining discount rate schedule compared with using a constant discount rate of 4%. Let us watch excerpts from the Weber lecture by Weitzman that reiterates the points raised by Arrow et al. And an interview with Stern for a critique that instead of using declining discount rates, we should adopt a near zero discount rate for climate change relevant public policy.